After your next meal, don't sit down. Walk. Not a workout, not a hike, just walk, gently, for 2 minutes. Around the kitchen if that's all there is. And something will happen in your bloodstream that is genuinely difficult to achieve any other way. Here's the part that surprised me. The effect doesn't come from burning calories. 2 minutes of strolling burns almost nothing, a few calories, less than a biscuit. That's not the mechanism at all. The mechanism is that a contracting muscle opens a door that is normally locked and pulls sugar out of your blood without asking permission from the hormone that usually controls it. That hormone is insulin. In most people's minds, it's the only thing that moves sugar out of the blood. And that is simply not true. There's a second route. It's been known for decades, and almost nobody outside of physiology has heard of it. Your muscles are the largest sugar sink in your body. Not your liver, not your fat. Muscle. And whether that sink is open or closed depends, minute by minute, on whether the muscle is doing anything. So the 2 minutes aren't about effort, they're about a switch. And the timing of that switch matters more than almost anything you could do in the gym later. This is a channel about mechanisms, not advice. I'm not going to tell you what to eat. What I can do is show you the plumbing, where the sugar goes, which doors it uses, and why walking is the cheapest way to open one of them. 2 minutes, no equipment, no sweat. Let's look at what's actually in your blood right now. Section 1. What actually happens after you eat? You swallow, and within minutes your gut starts breaking carbohydrate down into glucose and pushing it into your bloodstream. Blood glucose climbs. In most people it peaks somewhere around 30 to 60 minutes after the meal, then comes back down. That rise and fall is normal. It's supposed to happen. Your body isn't alarmed by it. What matters is the shape of that curve. A gentle hill is unremarkable. A sharp spike, repeated several times a day, every day, for years, is a different kind of load on the system. As glucose rises, your pancreas releases insulin. Think of insulin as a key. It travels in the blood, arrives at your muscle and fat cells, and unlocks them so glucose can get in. But the door itself is the interesting part. Glucose can't drift through a cell membrane on its own. It needs a specific transporter, a protein that physically carries it across. In muscle, that transporter is called GLUT4. And here's the crucial detail. Most of your GLUT4 isn't sitting in the membrane waiting. It's held in storage inside the cell, in small packages, doing nothing. The door isn't locked. The door isn't installed. Insulin's actual job is to tell those packages to move to the surface and install themselves. That's what unlocking means here. Doors get delivered and fitted, and then glucose can come in. Section 2. The second key. Now, in the 1980s, physiologists established something that ought to be far more famous than it is. Muscle contraction moves GLUT4 to the surface as well. On its own, without insulin. A completely separate pathway arriving at the same destination. When a muscle contracts, it burns energy. Its internal fuel drops. That drop is detected by a sensor inside the cell, an enzyme that acts like a low-fuel warning light, and that sensor triggers the same delivery of transporters to the surface. So you have two independent ways to open the same doors, hormonal and mechanical. Insulin asks politely from outside. Contraction opens them from inside. And this is where it gets genuinely useful. Because in insulin resistance, the condition underlying type 2 diabetes, it's the hormonal route that stops working well. The key stops turning properly. The contraction route is largely independent of that. The muscle can still open its own doors by working, even when the hormonal signal is being ignored. This is one of the reasons movement is central to managing blood sugar, and not merely a nice extra. Now, a caution I want to place right here rather than at the end. This is a mechanism, not a treatment. It does not replace medication, and nobody should adjust anything they've been prescribed because of a video. But it does explain something people find strange. Why a short, easy walk can matter more for that particular hour than a hard workout you did yesterday. Section 3. Why muscle specifically? Because the size of the sink determines how fast the water level drops. Skeletal muscle is the largest tissue in the body by mass in most people, very roughly a third to a half of your body weight. Nothing else comes close as a place to put glucose. And after a carbohydrate meal, the majority of the glucose that leaves your blood goes into skeletal muscle. Not the brain, not fat. Muscle takes the bulk of it, which means the single biggest variable in what happens to that glucose is whether the largest tissue in your body is currently doing anything at all. Sitting still after eating is, from the bloodstream's point of view, closing the biggest drain in the house at exactly the moment the tap is running hardest. And the fix isn't intensity. Studies of light walking after meals consistently find the benefit at an easy pace. You're not trying to deplete the muscle, you're trying to switch it on. Standing helps too, but less. The difference is that standing is mostly a static hold, while walking is a repeated contraction and release of very large muscle groups. Repetition is what moves transporters. Section 4. Let's follow the timing. You've finished eating. Instead of sitting, you stand up and start walking gently. The first minute, your leg muscles begin contracting rhythmically. Fuel inside those cells starts being consumed. The internal sensor registers the drop, and the delivery of transporters to the cell surface begins. Minutes 2 to 10. Glucose from the meal is arriving in the blood in quantity right about now. And it arrives to find the doors already open, in the largest tissue you have. Minutes 10 to 30. This is where the meal would normally be peaking. Instead of the sharp, narrow spike, the curve flattens into something lower and wider. Same meal, same amount of sugar, different shape. And that flattening is the whole point. Not less food, not fewer carbohydrates. The same meal handled differently because the sink was open while the tap was running. You can stop after 2 minutes and still get part of this. 10 minutes gets you more. But the sharpest returns are at the beginning, which is the opposite of how we usually think about exercise. And the window matters. A walk 2 hours later is a fine thing to do, but the meal has already been processed. You want to be moving while the glucose is arriving, not after it has been dealt with. Section 5. Now the strangest part of this whole story, and the newest. There is one muscle in your body that breaks the usual rules. It's called the soleus. It sits underneath the calf muscle you can see, deep in the back of your lower leg, and its job is unglamorous. It keeps you from falling over when you stand. Because it holds you upright all day, it's built almost entirely from slow, fatigue-resistant fibers. It is unusually hard to tire out. Most muscles complain within minutes. This one is designed to work for hours. In 2022, a research group published work on isolating and activating this muscle in a specific way while a person stays seated, repeatedly raising the heel with the toes planted in a particular pattern. What they reported was striking. Sustained elevated glucose oxidation for hours in a seated person without the fatigue you'd expect. The muscle appeared to be running largely on glucose drawn straight from the blood. I want to be careful here because this is one study group and a small number of participants. It is not settled science, and you should treat the specific numbers with caution. But the principle underneath it is solid and well established. That principle is the point of this whole video. A muscle that is working is a muscle that is eating glucose, and it does not need permission from a hormone to do it. Section 6. The protocol. 5 steps, and the last one is the one everybody gets wrong. Step 1. Start within about 15 minutes of finishing the meal. You're trying to be moving before the glucose arrives, not after. Step 2. 2 minutes is the minimum that shows up in the research. 10 is better, 15 is plenty. Beyond that, you're into ordinary exercise, which is good for other reasons. Step 3. Easy pace, conversational. This is not a workout, and it does not need to feel like one. Pushing harder does not open the doors any wider. Step 4. If you genuinely cannot walk, a small office, a plane, bad weather, then stand or do the seated heel raises we just talked about. Any contraction of a large muscle beats none. Step 5, and this is where people fail. Do it after the meal that matters most, not the meal that is most convenient. For most people, that's dinner, the largest meal, followed by the longest stretch of sitting still. The honest part. This flattens the curve after a meal. It is not weight loss, it is not a diet, and 2 minutes of walking does not offset the meal in any calorie sense. Anyone telling you otherwise is selling something. If you have diabetes, are on glucose-lowering medication, or use insulin, movement interacts with your medication and your levels in ways that need actual medical supervision. Talk to your doctor before changing your routine, not because of a formality, but because the interaction is real. Also, most of the research here is short-term and measures the glucose curve, not decades of outcomes. The mechanism is solid, the immediate effect is well replicated, and the long-term picture is a reasonable inference rather than a proven fact. And the Soleus work I mentioned is genuinely new and comes from a small number of participants. Interesting, plausible, not yet confirmed. I'd rather tell you that than pretend it's established. So let's put the machine together. You eat. Glucose enters your blood. It can only leave through transporters, and most of those transporters are parked inside your cells doing nothing. Insulin is one way to deploy them. Muscle contraction is the other. And your muscles are the biggest destination there is. 2 minutes of easy walking. No equipment, no cost, no sweat, no membership. It works on the largest tissue in your body using a pathway that was there long before anyone measured it. If you've watched the others here, you'll notice this one is different again. Humming, the doubled breath in cold water, were about pressing a brake in your nervous system. Morning light was about setting a clock. This one isn't a signal at all. It's plumbing. You are not persuading your body of anything here. You are opening a physical channel in a cell membrane by making a muscle shorten. It's about as mechanical as biology gets. And I think that's why this one bothers people. It sounds too small to matter. 2 minutes isn't a discipline. It isn't a program. There's nothing to buy and nothing to track. It just quietly changes what happens to your next meal. Every one of these videos has landed in the same place. There is machinery inside you that was running long before you understood it, and a handful of its inputs are sitting in plain sight. Sound, pressure, temperature, light, and now, simply, movement. So after your next meal, don't sit down straight away. Walk for 2 minutes. Nothing dramatic will happen. You won't feel a thing, and that's rather the point. The work is happening in a place you have no sensation of at all.